Section 8.3, example 1, graphing a parabola with the vertex 0, 0, and the x-axis as the axis of symmetry. Graph y squared is equal to 24x. Identify and label the focus, the directrix, the endpoints of the latus rectum. Oh, lots of stuff to talk about here. So I bet back in chapter, I don't remember the last time we talked about parabolas, but you thought that this was the last time you were going to ever see parabolas. Well, guess again. Conic section has its own form of parabolas. So let's see what we need. So they want us to find the focus. I'm sure they were talking about the vertex too. So let's start off with that. So vertex, let's do it this way. So vertex, the focus, directrix, and the endpoints of the latus rectum. All right, starting off with the focus. So different possibilities with parabolas. So before we knew that they could open either upward, open downward, but here in this section, these are no longer functions. So we could now introduce a leftward opening parabola and a rightward opening parabola. Looking at this, it's y squared. So it's going to be coming off of the x-axis. So we're coming out either leftward opening or rightward opening. Let's get it into the proper form. So for a left and right opening parabola, it's going to be in the form of y minus k squared equal to p x, or actually 4p x minus h. So 4p, p is what's going to actually help us graph everything. So let's put this all into the proper form so we could just read things off. So y squared is equal to 4p. So 4 times what will give us 24? 4 times 6. So 6 is what p is right now. And then we just throw the x in there. So vertex, since we don't have anything inside the parentheses, anything immediately following our input and our output, our vertex here is just going to be 0, 0. All right, let's start graphing it so we could see what's going on here. All right, so vertex here at the center, or vertex there at the origin. And next we're going to talk about the focus. So from here we have a focus p units away from our center or our vertex. So again, y squared tells us that it's either going to open left or it's going to open right, the vertex there in the center. Since p is positive, we're opening up in the positive direction. So right is our positive direction. So we know, I'm just going to kind of outline it just so we could keep it in our heads. This is what our graph should maybe look like. Open, or actually let's just draw an orientation here. Little arrows. That way we don't confuse ourselves with the actual graph. All right, perfect. So that tells us that from our vertex, we're going out 6 units in the positive direction. So 6 units, we go up 1, 2, 3, 4, 5, 6. This here is going to be our focus. So focus at 6, 0. Next, we have a directrix. So from our vertex, we go out p units from the vertex in the opposite direction. So going out p units this way. 1, 2, 3, 4, 5, 6. This one here is actually a line, and in this case, it's a vertical line. So the directrix in this case is x equals -6. And the cool thing about the directrix, each point on the graph is equidistant to the directrix as it is to the focus. So from here, the vertex, which is our main point, is the same distance to that focus as it is to the closest point on the directrix. So because of that, what we could now make up is going out 2 p units out this way, because we have p right here, right? So 2 p units out this way for it to hit this at a 90-degree angle and be the closest point to that point. So those are the points that make up the lattice rectum. So we go out p units in the left or up direction, p units, or 2 p units in the down direction. So since p is 6, 2p is going to be 12. So we're going out 12 units from our focus. So 1, 2, 3, 4, 5, 6, 7, 8. And we don't have enough room. In just a second. All right, so 2, 4, 6, 8, 9, 10, 11, 12, 13, 14. Actually, we just had to go out 12 units. So here and here. So 12 units there. We need another 12 units down here. 2, 4, 6, 8, 10, 12 is here. So those are the 2 points that make up the lattice rectum. So here, this is the point when x is 6, y is 12. And also when x is 6, y is -12. Our graph ends up being from here out this way, going in that direction. And from here out this way, going in this direction. So 6, 12 and 6, -12. And there we go. One more time, we had p units here, p units here, 2 p units here, 2 p units here. And notice at this point up here, 1, 2 p units here, 1, 2 p units here. So it's the same distance to our focus that it is to the closest point on our directrix. If you have any questions, please feel free to ask. Otherwise, bye.